it might be worth referring back to the first pitch, because when I started making the film, it was really about observing weather. It was about observing clouds, and time was an element of it. But I found that the more that I explored that subject, the more it became about perception of change. And as one of the physicists in CERN mentions at the beginning, in many languages, weather and time are actually the same word. I don't know how it is in Slovenian.
Tempo in Italian it's also the same.
Yeah. So that's one thing. The other thing is, I mean, the more I delved into researching it, it seemed to be a very time as a word, as something we try to find, is very human. It's how we try to perceive this change and perceive this being. And another title for the film could have been The Time Being.
And I have a question for you also, because it's not... you tell me recently that actually when you worked in CERN at the beginnings in the 80s, you made an experiment so that, if I explain it very simply, it would be that the time from A to B is not the same as from B to A when we come back, or something. So please explain.
Well, let me first say that the perception of time, it's very individual. Yeah? And it also depends on the age of your age. The perception when you are very young, when you are a child, 1 year is the whole experience, or a few years is the whole experience you have. And you can even not imagine what will happen when you will be 80 years old. When you are 80, you know that there will not be another 80. So, time is shrinking. But physically, scientifically, I mean, this is an interesting quantity which is very difficult to define. One definition, which is maybe not very serious, but somebody said that, well, time prevents the things happen at the same time. For me, it's interesting. But if you go to your question, yes, actually, I was involved in an experiment when we were trying to define the arrow of time. The arrow of time in the macro world is well known. There are several definitions, we can talk about that a bit later. But in the micro world, all the laws of physics are symmetric to the arrow of time. It doesn't matter. If a reaction goes in one way, it will go with the same probability backward. Yeah? So it's completely symmetric. In macro world, it's completely asymmetric. So that was an interesting scientific question, and we made an experiment, and we find out that there is a very tiny difference between if you change the matter to antimatter and antimatter to matter. It's a very tiny, it's almost the same probability, but with a tiny difference. Antimatter to matter goes with a slightly higher percentage than antimatter to matter. And what is the consequence of this tiny difference in time? The consequence is that our universe is made of only of matter. There is no antimatter in the universe, because in the development of the universe, this tiny difference was so important that the antimatter disappeared and only matter remained.
Interesting. So what is then the beginning of time? What does the beginning of time means for the history of the universe? What is the end then?
Both questions. We'll need more time than we have probably, but I will try to be short. The beginning of time. We know that, we believe today that the beginning, and there are proofs that our universe started with a big bang. Yeah? And with all the accelerators you've seen at CERN, scientists are trying to study the basic processes immediately after the Big Bang. But there is a tiny interval, which is around 10 to the minus 45 seconds. It's really tiny, where we don't know anything what was happening at that time, because that's the, let's say, the interval in the evolution of the universe when quantum gravity takes the major interaction. Yeah? And we know almost nothing about quantum gravity, so we don't know what happened really in the first 10 to the minus 45 seconds. It may be that the definition of time we have in the known universe was not the same at the beginning. And so that the tiny interval, which we believe that it was so tiny, may not be so tiny, because maybe there are processes which we don't know and which prolong that period. Yeah. So from the point of view of what we know today, it was a very tiny beginning of the universe when we don't know the definition of time. But maybe sometimes in the future, when we understand the quantum gravity, we will find out that this tiny interval was quite long. So, you know, with actually the scientists, we don't know what was the exact beginning of time, because we don't know what was the exact beginning of the universe.
And you don't know what was before. I mean, that's a question that I heard being discussed at CERN, the hypothesis of before the Big Bang.
Yeah. Well, the end, that's even a longer story. Because, well, let's say 30 years ago, we believed that our universe is expanding with a constant velocity. Yeah? And we hoped that this expansion will end at some time and will go back to the Big Crunch. Yeah? What was missing in the universe, at least we believed that it was missing, was the mass. If the mass was big enough, at long distances, the gravitational force will start pulling these things again together, and the universe will start with the Big Bang, expand, and then go to the Big Crunch, and then again and again. And that's nice, because you don't have the beginning and you don't have the end. Yeah? You have an oscillating universe which has no start and which has no end. So that, and also from this point of view, the time is infinite. Yeah? But in I think it was mid-90s or late 90s, there was a discovery that the universe is actually, the expanding of the universe is accelerated. Yeah? The velocity of the expansion is getting bigger and bigger. And at the same time, we discovered that we know only what we see, what we are made of. This is only 5% of the universe. The rest is dark matter, which we know that exists, but we don't know what it is. And the rest, 68%, is dark energy, which we even don't know what it is. But it's the needed ingredient which expands the universe with acceleration. So if this is true, the beginning is difficult, because, you know, physicists, we don't believe that things happen by chance in one place or in the other place. Yeah? There must be a reason that they appeared there, and we found no reason. Yeah? Why the universe started exactly 13 billion years ago in a part of the empty space? Well, some scientists will say, well, that's possible. That's possible. It's a fluctuation of the vacuum. But some others said, well, look, if this is true, we need a God. We need somebody who, at some stage, in some place of the universe, starts the creation of the universe. And then he can, if you put the right ingredients at the beginning, of course. And and then but this we don't know. I mean, if the dark energy will accelerate the expanding universe for, let's say, forever, then the universe will be bigger and bigger, colder and colder. Some processes will stop. The, let's say, black holes will eat all the matter will disappear, it will all be in the black holes. The black holes will irradiate the Hawking energy, Hawking radiation, and they will disappear. At some stage you will have only radiation in the universe. The radiation will later on disappear, and you will end with a vacuum. And that will be the end of the time. Yeah. But we don't know. Yeah. Which scenario is the right one? So there is a lot of work for scientists in the next decades to find out and, well, say, finally, let's say, also say, well, we know when the time will end. To make a long story short.
There is also, well, I just remembered when we made a documentary with Margherita Hack, also the astronomist from Trieste. She said the science doesn't give answers to why something has happened. So why the time? Why not just be now? Why the time? So she said, Anya, help me, because we made this documentary. She said the science doesn't give the answer to why the universe.
Why the universe is there?
Yeah. You don't know. The artist knows?
No, I don't know. Sorry.
See.
I wish I knew.
Yes.
Actually, no, I don't wish I knew.
Okay. But why the time is not now? Only to be now and nothing else.
That's how the nature is made. I mean, yeah, we cannot change the nature. We can understand the nature, but not change it. And, why? You can say because the Creator wanted to be that way. I mean, or you can find some other answer, but we don't know. We don't know why. We don't know why the universe started in 13 billion years ago, and why it started in a place we even don't know if it started. Maybe it's oscillating. Yeah. So there is a lot of more work for scientists. Yeah.
But I think you're also asking about perception of time,
Yes.
right?
Yes.
You're asking why do we live in this kind of position of referring backwards and anticipating forwards, often more than we are in the moment that we're in.
Yeah.
But I think that's very much how our minds are organizing change, are organizing experience into a time frame.
Mm-hmm. So yes.
That's a basic question. Why we have an arrow of time? Yeah, it's really a very basic question, and we don't know. We just know that we have an arrow of time. Yeah, and well, there are at least 3 definitions of the arrow of time in the macro world, which we know they are there, but we don't know why is that way. And these 3 definitions are: one is based on the entropy, which is a physical quantity which deals with disorder, let's say. Yeah. The second definition is well, it's actually psychological. Nobody knows why we remember the past and why we don't remember the future. Yeah. But this is clearly an arrow of time. So the arrow points towards tomorrow, and not towards yesterday. Yeah.
But may I interrupt? It's interesting that you go yesterday and tomorrow, because there's cultures, for example, in South America that go yesterday and
today
tomorrow.
and tomorrow.
Yeah. I mean, just it sort of enhances the psychological aspect. Yeah.
Yeah, and the third definition is simply it's cosmological. We know that universe is expanding, and all these three definitions point in the same direction. That's fascinating in a way. Yeah, but if you have, but this might not be true forever. If you have an oscillating universe, in the second part, once you reach the bigger size and then it starts decreasing, the arrow of time will point to the different direction. Yeah, from tomorrow to yesterday. Yeah, but again, we don't know. We know nothing about crunching the universe, because the universe, when we live today, the universe is still expanding.
I don't know anything either, but I'd like to explain something, which somehow seems relevant, but I'm not even sure why, and maybe you know more than I do. That circle at the end of the film is it's called Harmonium, and it's a project that two composers actually did, Bruno de Gesio and Christos Hatsis, and it's a visualization of harmony, of sounds. So if you take a violin string and you push it in the middle, you create the first harmony, and if you push the 2 points in between, you create more harmonies. So what they did was they took the string and made a full circle, and all the different points around the string are harmonies, which are joining lines, and we hear them. So what you see is what you hear. And like I say, I don't really know very much about why I was attracted to this in terms of time, but it seemed to me that music, again, and harmonics have some connection to time. If we hear a melody, obviously we're hearing notes in relation to the arrow of time that gives us some kind of satisfaction, I guess. And yeah, well, that's as far as I'm going to go with that.
Can you add something?
No.
So you,
No, because perception of time, I know very little about the perception of time, but it's an important issue, and probably it's closer to the artist than to the scientist. Yeah.
but it's close to you personally, as Danilo Zavrtanik. It's perception of time. But you can also express it in a way. What is perception of time for you personally, as a human being?
The perception, my personal perception of time, it's very scientific. It's not. No, I mean time. Well, I don't know.
Good answer.
I don't know the definition. I don't know. It's.
Yes.
Since we have both the scientist and the artist, I would like to ask the scientist if the artist can add something that you know about time from his perspective. What he's saying about time in his this film.
The question was if scientists can contribute to the.
No, if the artist can
the artist.
contribute something.
Yeah, of course. I mean, every understanding, every possible way to understanding the time and the perception of time can come not only from scientists, can come from artists, of course, why not? I mean,
Because a few years ago we have this film by Denis Villeneuve, I think, Arrival, that it's basically a science fiction that's telling that alien race come to Earth, and they are explaining to Earth people that there are also other concepts of time. That time is not just linear as it goes, but it can be perceived as a whole. That means that the past, the now, and the future is at the same time they're happening.
Well, you know, this simple perception of time, that you just have a flow of time which goes and goes and goes, and well, personally, you may think that it goes fast, or you may think that it goes slow, but you know, this is a very simple definition, which is actually it was actually a scientific definition from Galileo till Einstein. I mean, everybody believed that the flow of time is just there and it's flowing, and you just need to define a second or a minute or a day at the beginning, and that's it. And then you can things measure, and you can explain how you move in time, and how you perform in time, and so on and so on. But well, with the relativity, the things has changed really, because time is not anymore a parameter. Yeah? It's part of your world. Your world is built in 3 dimensions, which are well, left, right, up. But there is the space in which you live is not 3-dimensional with a flow of time, but it's 4-dimensional. Yeah? So the time is not anymore a parameter. It's a coordinate in your life. Yeah? And that's changed a lot the perception of time, scientific perception of time, because it also predicted that the clocks are not showing the same time in different parts of the space. Yeah? If you are accelerated in the space, your clock will slow down, and you will live longer. Live longer for the other person who is there. But in fact, biological processes will be the same. At the end, you will die at 80, or I don't know, 90, or whatever. So the relativity has really changed a lot, the scientific perception of time. And but maybe we need some more input in the future to understand it better.
Do you have any questions in the audience? You are afraid of the scientist? Yeah. So, can you explain what really happened with this Higgs boson? So this kind of the God's particle. What is there any? Was it found? What happened?
Well, I told you before that I'm not anymore in the particle physics for the last 20 years. I made a change in my life, in my scientific life, and I moved to astrophysics, so I'm an astrophysicist, although I was educated as a particle physicist. So I'm still following the particle physics, but I'm not anymore, let's say, much involved in that respect. So about Higgs, I'm afraid I cannot tell you much. I mean, it was discovered. It was but scientists were looking for it for many, many years, decades, and finally, with the new machine, with the LHC machine at CERN, they discovered it. This is a discovery which was, I think, a modern discovery, which with a lot of PR and the rest of. Also, the name, the God particle, it's completely out. I mean, it cost more troubles than it did good. But you know, we are living in PR time and
show business, right?
Yeah, show business. Even scientists, we have to do some show business today. Otherwise, you are not existing. This is an important building block of understanding the matter. You know? So why we have mass? That was before the Higgs theory. nobody knew why we have mass. All the equations, all the standard model could work perfectly without mass, which would be fine for us. Everybody will be very light. Yeah? But I mean, the nature is not made of the nature has mass. Yeah, and to understand why we have mass, why we are not massless, we needed to prove that there is a theory which predicts the Higgs boson, and the Higgs boson is a particle which some mechanism gives mass to the bodies. That's more or less what I can tell you, not more than that. As I said, I'm not...
And I mean, it might be worth describing, it is visualized in the film, but how these particle accelerators work is an incredible thing, because you're shooting the particles around a 27-kilometer or mile ring, and they collide inside these big disks, which are many of them. Right, you see them in the film on the surface, but they're also several deep, and this collision takes place. And you can correct me if I'm wrong, by the way. The collision takes place, and the shattering particles go through all these handmade plates that are detectors, and it's an immense volume of information that immediately goes to well, you see the rooms in the film as well, these computers that process the data and throw something like 98% of the data away and keep 2% of the relevant data, and then that data goes around the world on a unique kind of data pipeline that is for scientists all over the world. So it's this mind-boggling instant of a collision that turns into data that goes around the entire globe for scientists to evaluate, to try and figure out the answer to what you just described. It's a kind of extraordinary structure.
Yeah, and also, I mean, this would not be possible 20, 30 years ago, because, for example, one of the reasons is you mentioned computers. The computers today are much more powerful than they were 20 or 30 years ago, and with this amount of data, 20 years ago it would not be possible to I mean, the world computer power was not enough to process all this data collected at the LHC. Yeah.
I have a question for you. Not you, you. Don't hit him.
Sorry, did I give you a hard time?
I'm used to it. I'm a rector of a university.
I'm just curious, I have my own theories, but what do you think artists and scientists have in common? And what do you think they also might have in common in their working methods?
I think the most important thing we have in common is creativity. You need it for science, and you need it for art. And it's basically the same. It's not different, you know. Without creativity, you will not be a good scientist, and you will not be a good artist. So this is, I think, the most important common point we have. And of course, we do our work. I mean, we do our work in science, we do our work in arts, but the basic thing is the same. So we are not that different, huh? Not that different.
That was my kind of discovery when I went to CERN. In fact, I always had the impression, you know, physics were rules and these things were set. And as I started talking with people there, I realized, oh, well, there's a lot of philosophizing going on, and there's a lot of wonder going on. And one of the terms that physicists use that I really appreciated was this idea of basic research. And
I think that artists and scientists, we have to go beyond. We cannot stay on what was already done. We have to go beyond. And it's completely, it's the same process if you look at a scientist or if you look at an artist. The person who is not brave enough to go beyond will never be a good scientist and probably never be a good artist.
I think was really a good closure, and now it's time to stop. Ah, you have.
Maybe it will be a little bit more abstract, but both of you can answer. Do you think that in dreams we experience time, or that, as you said before, that for some reason we remember the past, but we don't remember the future? So do you think that maybe in dreams we remember the future, or just your opinion about how we experience? Because also we can dream something like 20 seconds, but in the dream it seems like we've lived the whole lifetime. So it's not compatible. So just an opinion.
I don't know if I understood the question correctly, but your question was why you don't understand the future, or? No. Yeah. Yeah. I don't know. Well, again, I'm not a specialist, but you. I don't know. Well, I don't understand the dreams anyhow. So, but could be that dreams have some connection with what. Well, many times the dreams have a connection with what happened to you in the last, I don't know, few days, months, sometimes even an event which was far in the past comes into your dreams. And maybe if you don't, next morning, if you don't remember what happened 10 years ago, but it appeared in your dreams, you will say, okay, this will happen sometimes in the future. I don't know, maybe. Yeah, maybe. No idea.
I don't know. But it's interesting to think of dreams and films, because films are a kind of conscious manipulation of time. I mean, the film you just saw is it's a complete manipulation of a time experience, as is all cinema, because it's always editing and it's referencing forwards and backwards, with the privilege of a creator behind it who can tell you the future. So, I've often asked myself the same question. In reality, is there a way to move forward, to see forwards? And that sort of abstract sequence at the end of the film, to me, is a very aggressive manipulation of time. I mean, it's bending time, it's layering time, it's moving backwards, it's moving forwards, it's putting images on top of each other in a way that, I tell myself that that's a kind of film of the future, and that's a possible reflection of our consciousness as we move forward with technology and image language, and it's a possible way of our dreaming working. Because, like you say, in a dream, something can take 20 seconds in real measured time, but it seems like you've been in it for an hour. So that kind of process of layering and distorting time is something that I've been doing actually with this instrument for the live performances.
So, thank you. Now it's really time to stop. and because we go on, I'd like to thank you both very much, and also you especially, Danilo Zavrtanik. Sorry for the heat, and really, and thank you so much from the so we can, do we have a little time to just, you mentioned that machine?
Yeah. Do we have time?
Yes,
It's
I do.
amazing how many times you say time when you're talking
Yes,
about
yes.
time.
When I have a scientist here, it's all